bacteria found naturally in the wild, it's found in soil as well. Anybody's familiar with using urea as a fertilizer for corn and so on? You ever heard about that? Right? It's basically the same process that is in here that happens in the soil. When you apply urea or ammonia type fertilizers in the soil, those bacteria does the same thing. There's bacteria that breaks down urea into ammonia, and then nitrifying bacteria converts the ammonia into nitrogen that the plant can take on, right? And then some plants will also take on ammonia directly. But this process actually causes the water to become acidic, right? So we're going to be discussing a little bit more about this as we go along, but just an introduction to you. Now, those bacteria live all over the surfaces. Right? They live on any surface. Let's say, for example, an aquarium, right? They live in the water suspended. They live on the surfaces of the walls and the glass and everything like that. Any kind of plants, any kind of substrate like gravel and so on, they live on the surfaces. But when we're trying to grow fish intensively, so meaning a lot of fish in a small area space, there's simply not enough of that bacteria to do that in a regular time. That's why you have to set up on a separate filter to provide that amount of surface area, so we have enough bacteria that can convert the amount of waste that is produced by fish. Make sense? Any questions so far on this? Right? Don't worry, we're going to get more into this as we go into day 3, which focuses more on plant-based systems. Right? But just, this is a close which we're looking at. K1 by idea. This is available locally. It is quite expensive though. And when we go outside next day, I will show you guys a cheap, free biomedia that you can use. Right? Other things that are locally available, something like bio-walls that looks like this. Right? These are still more to be public ornamental industry. And this same process is also used in the commercial wastewater treatment plants. This is industrial biomedia, so the same thing that they used to do sewage treatment and so on to remediate that water is the same thing that they do. Right? So it's just on a smaller scale, basically for aquaculture. Now, just for your information, this is the procedure that actually happens in the water. Right? So there's ammonia that is produced. Right? And we'll talk a little bit more about ammonia because it can take several forms. But basically, there's two general species, Nitrosomonas and Nitrospiral, also Nitrobacter, that does conversion of ammonia into nitrate for us. Right? So that is an idea of what happens. Right? Now, when you're first starting an aquarium or an aquaculture tank, depending on what it is, whether it's a small tank or a large, thousands of gallons, it is all the very same process that you need to do. This is known as a cycle. And a lot of people, they start off with nice tanks, they put clean water, they put in water, they put fish into the tank, right? They get a nice filter, and they put the fish in. And they start to feed, and over time, they start to get diet of the fish and so on in a short period of time, right? And they wonder what was happening. Well, really, what happened is that they failed to set up system to cultivate bacteria. Basically, that whole process of getting bacteria to cultivate your filters, right? Because when you know what the heat is sterile, they have nothing living in it. It takes time to develop a biofilter. In tropical conditions, this usually takes about 50 days in more polar places. The more migrants, it's a lot shorter, maybe up to 40 days, right? And what that is the time that the biofilter takes to actually be mature, where it's actually working to actually pull the ammonia out of the water and put it into the sea. So what happens is that there's two ways to do this, right? There's a fishless cycle where you introduce fish into the water and you just boost ammonia into the water, but it's also ammonia. You can put, a piece of fish or a shrimp, anything that decomposes and will produce ammonia in the water. And what you will find is that initially when you're doing testing, I will show you guys a test kit that you can purchase globally and use to check this. Right? Is that you're going to have a spike of ammonia initially, right? And as those bacteria start to move, right, as they start accumulating in the system, right, you're going to have a decrease of this, right? So ammonia is going to drop down and you're going to get an increase in nitrogen, right? And you're going to have some nitrite, right? At the end of it all, basically, the takeaway from this is that you want to have only nitrates in your water, zero nitrite, and zero ammonia. Once you are at that point when you're reading, you know that the system is set. Right? If you're reading and you're only finding out you get in ammonia, no nitrite, no nitrates, it is not cycled. If you get in nitrite, no ammonia, and no nitrates, it is not ready. Stage where it is ready to add fish is when you have zero levels of ammonia, zero levels of nitrite, and only nitrogen. Right? And continually, as you're going around, you only need to do periodic water changes as your nitrate rises to bring it down again. Right? And then you go up. That makes sense? Right? Now, this is a test kit. It's known as an API, freshwater master test kit. And it's much cheaper than some of the meters that they have available. I will bring one and show you next day. It's probably like, I don't know, $20 for one of those meters. This is $300, right? Depending on where you are. Right? And it has tests for nitrites, nitrate, pH, and ammonia. Right? The method is quite simple. Right? Most of these things they come with a tube. Right? You fill up the tube up to the line, which is the water that you test from your system. There's your reagents in here. There's all the instructions in there. Usually just putting a few drops of each one in it, and it produces that color change after about a minute or so. What you then will do, for example, right, the pH test. You will go to the color charts, and you'll, on top of them, there's different things that you test for. So let's say I test the pH here. I will put this next to my pH, and I will try to match the color, right, with what I'm seeing here, and that will bring us our reading next. Right? So I will pass this around, and you guys can give it a look as well. So that's a good way to start to understand what's going on in the water. It's also a good diagnostic tool. And that was all that we need to finish up from last time. Alright, so I have some information to you guys. If anybody knows anybody who's doing aquaculture in a larger scale or maybe is thinking about it in the future, there are incentives available for persons who are looking to get into it. Whether it's aquaculture, so whether you're doing fish, whether you're doing ponds, whether you want to do aquaponics with fish and plants, there's all the minimum recommendations or the requirements to register, and all of the incentives that are available. So let's, for example, you have a tank system, you get back like 25% off on all the tanks or the PVC, you get 50% on a generator, blowers, water pumps, and so on, right? If you get into the ponds, there's incentives for vehicles as well. Right?
Sorry, does it have like a minimum amount of tanks or?
Yes, yes. So super tanks is a minimum of 15,000 gallons. Okay. And for ponds, it's a minimum of I think 7 years.
And this is where you have to go. You have to go to the county office right here. Oh, okay. It doesn't matter where country you are.
Yeah, because we are really the only aquaculture based facility here. We do all everything that's in aquaculture. Yeah, and even if you can't come, we can send you form digital, they can fill it out, send it back to us.
Yeah, we are registered farmer or?
Well, this will register. This is the procedure to basically register as a commercial aquaculture. So basically, this is like the fish farming version of registering as a farm.
So, in order to do it, whether we have to do it, right? Legal to do the same aquaculture.
The problem with currently, and I'm not too sure because I think you all might have issues with electricity with those uses. And that's really the feedback if you have from something like this. You might be able to do ponds.
Ponds, yeah, like you ponds.
Yeah, you do ponds, but if you have the tanks, you really can't always
More ponds.
Oh, okay, okay. Well, yeah. I guess once you do have a need for electricity, that will be so. will be sent to you guys as part of your packaging, right? So that one. So this is a little summary of it. Right now, I can do it on it. In certain programs in the government, it's not like you apply for it and you get back 2 months or a year. Sometimes it's 3, 4 years. Right? That's just relative. Go put the messenger. Just
A quick question, right? So you have to own the land and everything in which you do any.
Not necessarily. Once you have, you can have a permission, a letter of permission from the owner.
Affidavits or a letter? Just a letter?
A letter and will affidavit if it's needed.
Oh, okay.
And that will work as
That
well.
will work as well.
Yes.
All right, that's great.
What about the schools? Like if a school has a system and they have to buy certain things like pumps and so forth, do you all provide the service to schools who
Unfortunately, no. The school is interested. What they have to do is basically apply to the Ministry of Education to say that they want to do this project. They can write to us that we will be providing support in the building system or advice and so on, but the funding will really come from the Ministry of Education. So they have to.
What about a 4-H club? Like a 4-H club in the school, a club in the school.
We have done this, well, we have had, we have installed systems in school before, but that was with assistance of other funding agencies. So like Digicel, for example, we would have installed the special needs schools with funding came from Digicel. Also recently we installed in Whitehall and in Waterloo, but that funding came from the FE.
right?
So,
Like,
yeah.
but if it is like the club itself purchase your own pump and like there's subsidy, that's nothing like that.
No, unfortunately, no. This only caters to commercial size operations, so nothing in that case, unfortunately.
Okay. Thank you.
But there are some schools that offer CPP program.
Right.
What about maybe getting that out to more schools? Because not a lot of schools have that program with aquaculture or mobile farming.
Well, right. Well, what happens is that most of the schools that are interested, they can come to us and we can provide them with guidance. Basically, the funding as we sometimes are funded to feed our own personal sex, so it's just a
We are like provide seed seeds. If you all provide like fingerling to the school once you get a letter and stuff like that.
We sometimes will donate some depending on what we have, but generally if it's a large amount, we will just give you a contact for us. So what?
Okay. Yeah.
You all have people in place like you all take contact, you all have people in place like
Yes, well, we have to get technical guidance to basically guide your business, right? And that is advice of the business before you start. Alright, so we're going to talk a little bit more about tilapia basically today. Tilapia is a cichlid, it's considered a family of fish known as cichlids, and worldwide there are probably around there are probably around 3,000 species of cichlids worldwide, right? And always finding new types. But tilapia belongs, well, particularly Nile tilapia, as the name implies, it comes from the Nile River, right, in Egypt. And it's basically an African cichlid that is native to places in Africa, Egypt, and also Israel, right? There's also some other types around. But we actually have some local species of cichlids. Anybody want to give my guess on any species of cichlids that you know in Trinidad that actually indigenous to Trinidad? Australia. Yeah, that's what I was thinking. Sure. So we actually have two major species of cichlids in Trinidad and Tobago. There's the blue custard, there's the blue acara, and also there's a brown custard, which is another type of, it's a little bit larger than cichlid somatine. Right? But we also have, as you all know, that we also have tilapia in Trinidad and Tobago, but that is an introduced species, right? It was in way back when, it's in the 70s and 60s, and they were basically tossed away, most of them escaped, and it's really now cold, right? So we have Nile tilapia in Trinidad and Tobago, and we also have Mozambique, which is black tilapia in Trinidad and Tobago as well, right? In the wild. Now, a little history on the species. What you're looking at here is actually a mural that was found in Egypt, right? It belonged, this mural belonged to quite a wealthy person, a guy named the Barman, and he had basically a garden in Egypt, and he would have had fruit trees, and he also had ponds, and you can see he had birds, and he also had fish in there, right? Now, the fish that actually is in there is actually tilapia, it was Nile tilapia. The reason we know that is that Nile tilapia actually have a
I'll check it after class,
characteristic,
thanks.
at their tail, where they have these vertical bars. I'm not sure if you can see it too well, but the straight line is up and down. Right? But basically, it has a long history of being farmed. Probably one of the first species that was actually farmed in the history of aquaculture. Right? The other species that kind of predates this would be the carp in China. Right? But here we have some of the images of remnants showing tilapia from Egyptian culture. So it's a very important fish for that culture at that time. So much so that it was actually revered as a deity. Right? So in your ever heard about Egyptian hieroglyphics, the symbols and the signs, and they have different meanings. So in Egyptian hieroglyphics, right, you can see it over here. This is a zoom up version of it. This is the official hieroglyphics known as K1. That means that's tilapia whenever you look at anything in Egypt. Right? And the Egyptians, they believed that every day that you would see the sun rise up of the Nile River, go ahead and then go back down. Right? And they believed that in order for the sun to rise every day, it would have to take this journey underneath the Nile, under the water, and come back up the next day. And they believed that these two fish, known as Aptu and Anet, were two deified, like tilapia, that would guide the sun along a chariot until it came out the next day. Right? So there's a lot of history in Egypt concerning tilapia. Also, for those of you who might be familiar with Christian tradition, right? There's a lot of evidence to believe that this was the fish that actually fed the multitude. Tilapia, or particularly blue tilapia, is actually native to the Lake Blue Galilee, right? And there's the story where I think Lord asks Peter to go and catch a fish and open the small can and get a coin, right? Pay taxes and whatnot. There's another good evidence for this because tilapia actually mouth brooders. They pick up their young in their mouth and sometimes they pick up foreign objects, right? So a little bit interesting history there. Up to today, they still sell fried tilapia on those big Galilee trips in Israel. And these are some of the different types that you come across, right? So the blue tilapia, that's the one that is native to again, Israel. The Nile tilapia, this is the one that you find in the wild in Egypt, on Nile River. And these are red tilapia. Now, what happened is that early on, when aquaculture was now being a little bit interesting, they found that, there were certain markets that they were trying to target, so who would probably sell tilapia to. And in the US, there was always an existing market for red snapper, right, or redfish, right? And so therefore the acceptability of a redfish was much more greater, right, than something that was more silvery or darkish kind of color, right? And even today in Trinidad, everybody likes redfish, right? So everything is redfish. The Talapia, we have some redfish, right? But what they found is that they could crossbreed different types of tilapia. Most tilapia species are capable of being interbred together and producing viable offspring. So therefore, they would produce viable hybrids. And some of these hybrids would basically have tolerances. You guys did this much, I didn't hear before, right? So this is so when they crossbred some of them, they would get different specks of color. Some end up with gold bits, some end up with red bits. And over time, by continuous selective breeding, they would be basically able to produce a fish that has been all red or all cooler. This is known as a Hawaiian gold tilapia actually. And this is a typical red head that we find. Right, you guys will see some of those right here. When we walk through next Tuesday. Right? So why tilapia, right? Tilapia is such a popular fish. Well, you always hear about tilapia, but why is it so popular, right? And there's a number of reasons. One that we have here is that it feeds quite low on the food chain, right? What I mean by that is that tilapia basically aren't piscivorous fish, but they don't eat other fish, right? There are some instances where they will eat other fish. I will talk about that. But generally, it's a omnivorous fish that eats low on the food chain. It will eat things like algae. It will eat things like insect larvae. So, naturally, in the wild, tilapia eats something known as periphyton. And basically what this is a natural conglomeration of plant life, insect life, and mold that grows on the surfaces of materials, right? So if you want to feel a tilapia's mouth, when they open their lips, they actually don't have any teeth. What they do have is something that feels almost like sandpaper, so it's very rough. And what they do is that they grate and rasp on those surfaces, right? So while we feed them feed that tries to replicate that nutrition, basically in the wild, that's what tilapia is. So again, they don't accumulate a lot of toxins in their bodies as a result of they're not top predators like the kingfish and the carries and all those things, right? Also, like I mentioned, we do accept a wide range of food, right? So that's another benefit. They're not particularly picky or choosy, right? And feed can be formulated in different ways. I will be passing on some feed tabs so you guys can get an idea of the ingredients that they use today to feed them, but it involves usually fish meal, things such as soy, corn, and all that. But that's one of the things. Tilapia is one of the very few fish that you can actually formulate and feed utilizing most vegetable inputs, right? Even vegetable protein and it will grow well, such as soy protein and so on. Right? Whereas most carnivorous fish like salmon that we will farm, these are high protein content. Usually tilapia is probably one of the pure fish, or the very rare amounts of fish that grow on a low protein percentage. Typical protein percent for tilapia adults is around 52%, and that's quite low compared to 40 and 50%.
So you can basically use like fish that's right down the electricity.
Yeah, in fact, there's guys focusers in Africa who cannot procure expensive fish feeds to use, different types of things such as rice bran, cassava meal, moringa meal, to actually formulate their own fish feeds.
I saw that you have black fly.
That's what the fly project
Can
is
that
all
be
about.
used to feed them?
Yes, it can be used, however, quantity will need a significant amount of those things. And usually the difficulty with that is usually getting the amount of inputs. So the collection, this is typically what happens, right? It sounds regular paper, but the reality is that you have to be going out and spending a lot of energy to kind of collect that amount of food waste, unless you're actually producing that amount of like on a farm or something like that, that you can then feed to the actual flies to produce that amount of larvae needed to feed the fish, right? So that's the food, but it definitely can be used, so it's not a problem, and that is one of the things that's what we use. So they are also resistant to poor water quality. They're resistant to disease and rough handling, right? So they have very tough spines on them. They're not a soft fish at all. They will consider like a soft fish. So they have scales. Their fins are quite strong. These spines are quite sharp, so they will stick you if you're not careful with them. You're not using gloves. But it's a real hardy and real tough fish. So yeah.
So also all of the right? Which one is high in demand and shouldn't
Right, so right, that's what we asked that question last night, right? So, like what I mentioned, generally, persons tend to like the red hydrant, right? Because of the color, right? Not but when I say local tilapia, that's the same species of tilapia that we have in Guatemala today. So it's not a problem. But again, what happens is when these go in wild, these don't survive anymore. Because of the bright color in them, they're less likely, most of the predators actually use before they eat each other. Because they become larger than anywhere.
So you say the local ones, right?
Yeah.
That we have, cast, whatever, so we use this one, cast.
Or you talk about the
Yeah, why do they breed that instead? If
no,
it's
they
local.
only get about like 3 inches or so.
Oh, okay.
They're very big. People like eat them, people say castroma, so that's sweet fish, but they don't get very big, so there's not a lot of meat to see. Right? Yeah, but not as big as that. Right? You might get one like a size and thing, right? But not big like that.
Okay, so what was the biggest, what's the biggest size thing?
We would have had some tilapia here at about 7 pounds at the moment. We had a breeder that used to get about 10 pounds.
And how long that take? The same 6 months?
No. That is about 3 years ago. But you will see some large ones on the really good side, right? But yeah, they do get quite large. But again, because of the economics of it, the longer that you have to feed that fish, the more you have to charge at the end of the day to sell that product.
Right.
So the shortest time that you get an acceptable size fish, which is usually about a pound and a half, that takes about 6 to 8 months. That's kind of like the best balance. Also, the reds are sold particularly when you do fish of a smaller size. So because you'll be selling a whole fish that's around a pound, pound and a half, the whole fish is better to sell, right? If you do it fillets, it doesn't matter which one you choose. Because people not seeing the color of the fish, because they just get a fillet that skin off, goes off, and just package, right? Most of the fillets that are produced, that come from China is kind of tilapia, right? Because they actually grow the faster, and they're very hardy, and in particular, the tilapia have a tolerance to very low dissolved oxygen. So whereas they might be able to stress some of the other fish that might not survive under low oxygen conditions, or periods of low oxygen, the tilapia survive at very low levels of oxygen. Like people, actually farmers, or not farmers, but people who catch tilapia, cast and that kind of thing, is stuff, you know, them they don't need oxygen, you can put it in a bucket and you go about a while later and it's still filthy. So that's the thing, that's not cast Europe, but yeah. But difference is these do need to be breathing oxygen, it's just that they just have such a hard tolerance for oxygen, they can survive that long. Sure.
Aquaculture, where you usually let the combine something like that. Because what of the survive with
Well, tank-based systems, I mean, I would not recommend it. They are probably ones that will survive the most amount of abuse, per se, but usually it depends on the stocking density. Right? If you have a whole lot of fish in that tank, you know, 10, 20 minutes they're going to be jumping on the water trying to get in. Right? If the stocks are low density, they're probably right on the tank. I have a $1,000 tank there, in the back there, with about 10 fish, and currently go that full and cool there, but that's because there's a low stocking density.
Yeah.
So each of the fish doesn't need as much oxygen because it's enough surface area, enough volume. But if you have everybody packed inside it, right, it's like in a taxi and you knock up all the windows and all that air being used up, it will suffocate faster with more people inside. So that kind of thing, right? But tank-based systems, they need to have a backup, I would recommend. Right? So that's it. That answers the question? Yeah. So that's the only reason why I call it preferences. There are people who eat with their eyes first, so you know they like the fish look pretty and that's it. And again, good fresh flesh quality. They have done blind taste tests. I mean, if you're not a fish connoisseur, like you like eat snapper, you want to get the real good flavor of the fish. For the regular person, they've done blind taste tests with grouper, tilapia, snapper, cobia, and most of the people still pick the difference of tilapia to line. Right? So it's a good fish to eat. And in particular, it doesn't have a lot of strong flavor to itself. Oily fish in particular tend to have very strong fishy taste, you know. Tilapia is not a fish either. Basically, it's like a blank canvas, and that's why chefs like it so much because anything you season that fish with, they just take one and flip it. And chicken's like season, right? So and also reproduces quite readily. You really can't get a fish that is as easy to produce for yourself. You don't have to go to a breeder if you don't want to go through all that. You could breed it for yourself very easily, right? We talked about this is the fish that fed the multitude in the Bible, but if you hop on and you put a male and a female inside it, in about a year time, you could feed a multitude with that one. They will reproduce that fast and they will produce it. Yeah, they won't be small, but that's how fast they reproduce. And this is just a little bit of biology for you. Most carnivorous fish have a very short digestive tract. So if you have a cleaner redfish or a cleaner carrot, it's not a lot of guts, right? And tilapia is different. They have a very, very long digestive tract. They have a more bladder, and there's a lot of material inside of that gut. But basically, that is long in order to be able to digest all of that vegetable material. Right? So just proof of what the fish is designed to do. Right? So people who will say, it's really fish or is he coconut egg? This is what it's designed to do. It's similar to a cow, if you will. You'll know that ruminants have a very long digestive tract and they grass and so on. It's the very same thing with tilapia, right? Just in aquatic setting. So we have some images here in that tilapia, right? So like I was mentioning, the distinguishing characteristic is the caudal fin, right? The silver color and these vertical bars, right? Right now in the St. Joseph River, you can try not to make it in a lot of days right now. So let's see it. Right in the back. Yeah. Basically, that whole carny basin is full of these guys. And also the black tilapia. For those of you who see the videos of, I don't know if you all see videos of them catching fish by the Hyats, tilapia, and people just bought tilapia all over saltwater. Mozambique tilapia, which is a black tilapia, can live in water saltier than regular salt. Yeah, but they can tolerate full salt water and more. So people who live all know that is a fact.
There's a lot of foreshore as well.
Yeah, all the foreshore you see them tilapia. There's the up and down river.
Some big ones.
Right, so over time, they've been able to do selective breeding to produce fish that are a little bit more suitable for farming conditions, right? So naturally, in the wild, tilapia are a little bit more skinnier, a little bit more oval shaped. But over time, what they've done is basically produce a fish that's much more rounder. And what that does is that it gives you a fish that's deeper in body shape. More depth in a shape, meaning distance from the top of the fish from the dorsal position to the ventral position. That spacing gives you a much bigger fillet, right? So that is what some specific breeding has been doing to produce these more rounder type fish as opposed to the wild types. This is a picture of the Mozambique, right? I don't think I showed you guys that, but it's a very pretty fish. They're black. The males in particular have a very large scoop mouths, and they have little splotches of red on the edge of the fins here, on the top here, and all the pelvic fins as well. It's a very nice, beautiful fish. So for the guys who are asking, I think somebody is asking how you tell the males and the females apart, right? So all you need to do is just turn the fish over, right? You're looking at basically, right? This is how it's sexually determined the sexual object, right? You're basically looking at the genital area, so that is right before the anal fin, right? That's the last fin on the fish here, right? Right before there is the area that you're going to be looking at. With the males, what they have the anus here, this is where they have the regular feces and whatnot. And then they have a structure known as the genital papilla, right? At the end of the genital papilla is a small hole that is known as the ureter, right? That's where the fish produces urine, right? Basically. Freshwater fish basically pee all the time. They have to keep getting rid of fresh water in their bodies, right, to maintain a salt level. Right? On the female, there's the same anus here, there's the same genital papillae, there's the same ureter, but in the middle of that genital papillae, there's a small slit that is known as oviduct. That is when eggs are basically produced and exit the body where they will lay the eggs. Right, so basically the female has 3 holes, the male has 2. Right, so that's what you're looking at. So relatively quite easy to sex compared to other fish, which actually has most of their stuff internally sometimes. But this is only quite easy to recognize when the fish are larger. Right? When you usually sexing those fish, they're smaller and it's very difficult actually. So there's a few techniques that you can use, right? So generally, you can grow the males and the females up for a while in a hatchery until they get about, I don't know, probably about like 8 inches long, probably about 60 days old, where it's a little bit easier to start the sex time, right? And you always want to use a soft net, nothing harsh to kind of strip up the flesh and that kind of thing, right? Fish have a slime coat that's basically their defense on their bodies. So you don't want to damage that at all, right? So very soft net. And you don't want to pull that firmly. And what you could use is a little bit of food coloring, right? Here you can use a little bit of crystal violets, macaroon blue, and you can have food coloring that provide a contrast that helps you see that those structures a little bit better, right? You're going to get some bright light and you're going to look at it and you'll try to determine it, right? So test for you guys. What do you think this is? Male or female? Right, I see females and males, right? Right, so this is actually a female. Right, so you see the different structure. This is actually the anus here. Right, see how small it is? This structure is the genital papilla. This is what you're looking for. See that crescent shape? That is the oviduct. Right, so that is where that fish will actually reproduce the eggs when she gets old. Right, so that's what you're looking at. So yes, you see how easy it can be to mistake this a little smaller. It's only when it's starting to get mature where it becomes a little bit easier to tell at a glance. Right? This is the same thing with a female. And a little trick you could use is that's why I use a bright light. Because there's that indentation here, as you adjust the fish, you'll get that inflection of light on that structure right here. So you get 2 little inflections of light. Right? So here we see another female as well. Right? And this is when they become sexually mature. What happens is that the genitals will swell a little bit better, you get a more rosy color with blood and so on, and it becomes much more easier to tell. So this is a male, right, before breeding. This is a male that is actively breeding, so the organ is a little bit more engorged, and the structure is a little bit easier to see here as a female, right? So female here. Also on the underside, you'll kind of develop a little bit more color as well when the fruit here, right? So how Talapia would be, right? What happens is that the males are quite territorial, not untypical of regular men, right? They're always, right? So they have a little machismo, they have no fights, kind of chase out the intruders and whatnot. The bigger guy, you know, who more aggressive, will win. What they do, they open their mouth and they kind of compare both sizes instead of going back and forth like this, right? And the one that wins, well, he wins the game. So basically, he will prepare a nest. A tilapia nest is those that like L-E-K, and basically it's a circle in the ground, right? So if you have an aquarium and you have say gravel on the bottom of the aquarium, you will see almost like a perfect circle cleared out by that fish, right? Same thing for oscars, if anybody ever oscars. Yeah, perfect circle, right? Yeah, that's just the behavior, right? And what will happen, he will leave the female to there. The female will extrude the eggs in the nest, and then the male will go over it, and he will release sperm over those eggs, and he will basically fertilize those eggs in the nest. The next step is that the female will actually take up those eggs in her mouth and keep them there until those eggs hatch and those fry get larger. Right? The way that you can actually tell when the female is carrying those eggs is that little pouch under her chin will be a little bit extended, and you'll always see her doing a little movement. And what she's doing, she's constantly sucking in water, passing it over the eggs and through her gills. So she's always rotating those eggs in her mouth, providing clean oxygen over those eggs until they hatch, basically. Right? Also, you will notice if you have them in that tank, when you throw food, the females will come right up to the food and then they will stop. They won't take it. right? So that's one of the things with female tilapia, is that they do not eat for that entire period of time where they're raising their young naturally. Right? That could be sometimes up to 2 weeks. Yeah, about 10 days usually. It takes about, about 3 days or so sometimes until those eggs hatch. And then she raises them up for about 10 days until they become fish swimming. And like that. So, a tilapia, a female tilapia, once she's being fed properly, with feed in between feedings, every 2 to 3 weeks. Yeah, they breed very, very fast. So basically, they say every month or that's spawn out that female. Because as you will learn, there's techniques where persons will basically will not allow the female to raise the eggs in the mouth. They will collect the eggs, hatch them separately, and basically she will have another spawn almost immediately afterwards. So yeah, they continually breed. And this is one reason why tilapia is such a successful species anywhere they go in the wild. And that is because of the strong paternal and maternal instincts of the fish species. They're basically good parents. Right? So most fish generally, they are free spawners, meaning that they release eggs, they release milk into the wild, and that will just basically go wherever it is, hatch, put that there, very clean up with the right?
Do they breed for life if they don't, like, once they're in close, or do they
Basically they will breed continually for their lifespans, but as they get older they start to slow down.
No, what I mean, do they as a pair, like
No,
pigeons?
They don't pair.
Oh, okay.
They do not pair.
So they just fight and whoever wins.
Yeah,
Alright.
the stocking density for well we talk a little bit more about it, but the stocking density for breeding tilapia minimum is about 3 females to 1 male. Right? If you have them in a confined area and you just have 1 male and 1 female, that male just want to breed all the time and he will just harass that fish until she gets. That's reality, right? So what the technique is that you need to basically put females so that you'll
Tire them out.
attention all the time, so not one female suffering all the other, right? That's just the case. Right? So this is example when it dream and breed upon what the nest look like. Again, you say X to be these holes, perfect circles. Right? Now, you can raise those fish in ponds and allow natural breeding. But the technique for this is that you will stock a few colonies, right? You stock maybe about 3 or 4 units, meaning about 1 male to about 4 females in ponds. So, and they will kind of hold their own corners. And as they breed, the female will produce the fry, and when she finally releases them, they will come to the edge of the pond, in very, very shallow areas of the pond. And basically you have to be walking this pond every single day and looking for them and picking them up with the nets and then put them into tanks to raise them. Right? The problem happens is that periodically you want to be draining this pond, taking the fish out, sterilizing it, and then pulling it back. The reason why is that you will always have, you will collect back all the fry. Right? You'll always have 1 or 2 who escape. And those that get a little bit bigger, right? So let's say you have one that, a couple of them that get about 3 inches or so. Any other fry produced in pond, those juvenile ones will eat the upper fry. Right? No. It's juveniles. Right? So the thing about it, people will say, well, I told you it's up, I don't eat other fish, right? That's the exception. But the reason why is that naturally in a pond, the food that the tilapia are eating at that stage is zooplankton, daphnia, all those different things. But it's the same size as the fry. So they don't know that it's another tilapia. They just see these little things that go around, that is food, I eat it. Right? So that's really what's happening there. Okay?
So what about inbreeding?
Inbreeding is an issue. Tilapia are very inbred in many cases. But that is important for breeders. What they do is periodically they will breed new stock. Right? So they don't breed a single pair for however long, and they don't breed the generation daughters with sons back with the parents. Right? So to prevent this. So they will go and buy one farmer or they'll bring it from foreign and they'll go and replant it. Right? So this is natural breeding in a natural pond, right? Now this is quite economical because what happens is that you have to spend a lot of money feeding the fry and whatnot. Well, not the fry, but they tend to do a lot better in a natural system with natural food and so on. But because of these management issues, most businesses tend to go with a more, well, I'll show you what they will tend to do is that they will periodically collect the females that has the eggs in it that will fertilize, and they will collect the eggs and hatch the eggs separately, right? And yeah, I'm going to show you all that. But this is an example of what it looks like when the females carry the eggs. Right? And it's nice yellow color. Next slide. Okay. So, tilapia will produce the amount of eggs relative to the size, right? It's basically proportional to the size of the fish. So I have a graph here. This shows the number of eggs by 100, so it should be 100, 200, 300. And this is the weight of the fish. So basically, a 300-gram fish or a 400-gram fish will produce that amount, but they will produce about 300 to 400 eggs, right? And the reason why is that as the fish gets bigger, they get a bigger amount. So they will only lay as much eggs as they can hold in them. So how big? 1,000? It's probably about a year and a half or so. Yeah. And it depends on the variety, depends on the management, on the factors, but around that. That's how much usually, yeah, I'd say about like a 12 months or so, minimum for the bigger sizes. Could you? Yes, you could. If you what people do if you do them in tanks, like a lot of aquariums, you just put the male, and once they do their stuff, and you see she has eggs, you just keep putting it and just leave her in the tank herself. And that's it.
But sir, you were saying?
Yeah, you can do that as well. Yeah. She will lay, what she does, she will lay the eggs and she'll eat the eggs. Huh? Yeah.
But sir, you were saying it's only males that's being born, you don't put
This is
both
a breeding pond.
a breeding pond, okay.
Breeding pond. Yeah. We're not trying to grow the fish in it, basically. This is what you do to get tingle, to produce fry, to stop the other ones.
Right.
Right? And the time stage, like I said, it is dependent on temperature, so this could go a little bit faster. But this is how the eggs start to develop once they fertilization and they start to mouth. All of this will be happening in the mouth, right? At this stage, this is what we call the eye stage. You start to see two eyes forming on it. You see the tail emerging. And then, once they hatch at this stage, this is what we refer to as yolk sac fry. They cannot swim at that stage. So generally, when fish hatch like that in the wild, they basically just help us. They're sucked in water, so fish just kind of moving around. And what they will do is that they will absorb this yolk, so they do not need to be fed at that stage, right? Even at the stage that they're still pulling from the yolk sac, only until they absorb all of that. I said about 10, 12 days is when they are able to be fed, right? And then they will actually be free swimming, and they actually move around for themselves and so on and so on, right? A key thing to when you're doing hatcheries and so on, you don't want to have the tank very deep when you're doing fry, because all fish, well, typical fish, have what is known as a swim bladder, and when they're born, the fish are known as swim up fry, because they have to come up to the surface to grab a lot of it to inflate their swim bladder to have buoyancy in the water, right? So you don't want that water too deep, so that's why you're constructing a hatchery is more shallow.
2 feet, 3 feet?
About a foot or so.
A foot.
Or even less. Right? Some of those hatchery jars or not jars, because they're about 6 inches tall. It's a little more images when you develop that little fry. Right? This is a little blurry, but this is what it will look like when she has the fry in her mouth, and they have to move wild, so they still have the yolks attached to them. Right? And this is when she has them a little free swimming. A little bit to show you guys. see, I'll try to pull it up for you guys on the group, right? So this is an example of that hatch method that I was talking about where they collect the eggs, right? And what they have is basically fresh water that flows into these small tubs, right? So it's continually flowing, and the water exits these little holes that has a mesh over it. So I'll look at that in the shape. So you see there's some holes on the side of the containers. There's the mesh covering it to escape the egg, to prevent the escape of the eggs and the young fish. And that fresh water basically just rolls around those eggs until they hatch. And then they will just be there and you feed them and so on, move them to that next fish. So like I mentioned, persons who using blue barrels and so on, these work excellent as a hatchery type vessel that can be used. As you see, they just keep them in height with some other frames. Also, some of these food grade containers, they develop rubber plastics that can produce these food containers. Right, these can be used as well. And once the price is a little bit sized, a little bit bigger, you can start to move them with the eggs and so on until they reach a size that they sell and so on. So typically when they sell fingerlings, it's probably about a month old, generally, and about 2 to 3 years long. Probably around 5 grams or so. Now there's another type of culture known as cage culture, right? Where they do it in ponds, but instead of releasing the fish in the ponds, they have these little net structures. So this is a net pen, and it's known as a hopper, right? What they do here is that in each of these hoppers, they will stock about 7 to 10 females and 1 male, and every week or every day, they will kind of go through with this kind of structure designed to kind of sweep down this whole in the net and concentrate all the fish in this little pocket. And what they will do, they will go through, take out each of the fish from here, wash the see if it's the male, the trophy back, take out the female, if she don't have eggs, trophy back. When they pick up all the eggs, they open them out and wash it out and collect the eggs and put them back in. And every week that's how they collect the eggs. And then put it in the industry and they go from there. Right? So this is some young females that we see here. Apart from the vessels that I showed you earlier, some persons use some things like these, and this is produced for any kind of species of fish. These are known as hatching jars, but the concept is the same thing. What you have is fresh water flowing into this, and on the bottom of these containers, they are curved, they're not flat. So as a gentle stream of water, so you don't want the eggs compressing and hitting very hard to damage the eggs. It's a very slow, nice, gentle flow that will just allow the eggs to rotate very slowly. Right? And as the eggs hatch, they will basically flow out the top and into a main tank. Right? So this is one way we saw somebody do it as a nice cheap way to do your own hatching jars. With some bubbles. We have the PVC here that we want to be coming. Now this will be clipped on the inside of the tank and just showing you the outside of it. You see how it's constructed. Right? So those bottles will be suspended in the aquarium. There will be a small submersible pump that's connected to the tops. Here, with PVC for the inputs, the water will flow into the bottom, right? Roll around and it will flow back out into the top. So you see some of the eggs that are in the bottle, some unhatched, and the fry that will hatch, they basically swim out and come into the main tank. Right? Any questions you all have so far? Everything is okay? Technical difficulties. Alright, well, you guys going to take your break now and we will come back about 10:30. I'll try to get this.
What is that? Oh, now you go check it after. Yeah, thanks. What is it? Break?